In this video, we'll solve a second problem on the properties of fluid. Okay, this problem is also related to viscosity and shear stress and shear strain. We'll try to solve a problem. Okay, I'll try to read a problem first, and we'll try to write the data here. Okay, if you read the problem, a plate 0.05 mm distance from a fixed plate. You have two plates. One fixed plate, this is one fixed plate, and one is movable plate, and one more is you have one movable plate. You have two plates. What is given? A plate 0.025 mm distance from a fixed plate. It means this will be 0.025 mm, right? 0.0025 mm from a fixed plate. This is fixed plate, and this one is movable plate, right? Movable plate moves at 60 centimeters per second. Moves at a distance at a velocity of 60 centimeters per second. It means this will move at, it means its velocity u, then generally denoted by u equal to 60 centimeters per second, its velocity. Okay, this upper plate, and requires a force of 2 Newton per unit area. That is the force to move this plate. You need to move this plate. You need a force. Okay, that will be 2 Newton per meter square. Okay, F equal to 2 Newton per meter square. Force is required. It means just two plates. One is fixed plate. This is one is fixed plate. One is movable plate. The distance between these two plates are 0.025 mm. Okay, and the upper plate is moves at a velocity of 60 centimeters per second, and it requires, because you need a force to move that one, right? To move this one, the force is 2 Newton per meter square. Okay, determine the fluid viscosity. You have to find out the fluid viscosity between these two plates. The fluid viscosity is generally denoted by mu here. Okay, plates. This is how the given data. First we'll try to write the given data. Distance between plates. These are the distance between plates. Plates equal to this will be dy. Generally dy. It is the distance between two plates normally given by dy. It means final distance minus y2 minus y1, right? y2 minus y1 equal to dy. This is dy. That will be equal to 0.025 mm is given. Convert this in meter. 0.025 into 10 raised to minus 3 meter. This is the dy. Okay, next one. Moves at a velocity of 60 centimeters per second, u. That is u equal to velocity of upper plate. Just a minute, just velocity of upper plate equal to u equal to 60 centimeters per second. Okay, convert this into meters per second. That is 0.6 meters per second. This is the velocity is given. Requires a force of 20 Newton per meter square. It requires a force. Okay, that is F, force on upper plate. Force on upper plate equal to F equal to 2 Newton per meter square. Because the unit, if you see the unit Newton per meter square, this also be equal to shear stress. This you can also call it as, this will be equal to shear stress also. This will, I can call it as shear stress also, tau, denoted by tau. Okay. Next, what is the next line? Determine the fluid viscosity. You have to find out mu. Mu equal to how much between these two plates? How much is the viscosity, the coefficient of the viscosity we want to calculate here. These all are the data given. Now we'll try to solve the problem here. We know the formula here. General formula in the previous problem 1 we already know that that is the relation between shear stress and shear strain. The shear stress equal to mu into du by dy. This is the general formula, where tau is shear stress, mu is the dynamic viscosity, du is change in velocity, and dy is change in distance. We already know that, right? But he is asking to calculate the mu. We know that tau already we have here 2 Newton per meter square. We have tau here. Du and dy we have to check there. Okay, so du is, what is du here? Change in velocity, right? Change in velocity. So what is the change in velocity here? That is u minus 0. That is final velocity minus initial velocity, right? Initial velocity is 0. U minus 0 is, u is how much you have here? That is 0.6 meters per second. Then dy is change in distance. Change in distance. This already we know that is 0.025 into 10 raised to minus 3 meter. Just call this one as equation number 1. Therefore, now substitute all the data in equation 1. Therefore, equation 1 becomes tau. What is the tau value? Shear stress value 2 newtons per meter square here. Here already is there. Substitute that. 2 equal to, you want to calculate mu. Du is 0.6 divided by dy is 0.025 into 10 raised to minus 3. From this one you have to simplify and calculate the mu value. Therefore, mu equal to 2 mu equal to 2 into 0.025 into 10 raised to minus 3 divided by 0.6. Okay, so simplify and calculate. After simplifying, we will get the mu value equal to 8.33 into 10 raised to minus 5. Okay, what is the unit here? The normally the unit Newton second per meter. The viscosity the unit is 8.33 into 10 raised to minus 5. This is how we have to calculate the viscosity values depending upon the given data here.